In this video, we'll be discussing about the functions and the relations. So, before we go to detail, we first need to understand some certain terms that are so familiar with them. So, the first terms or the terminologies that we have in this video are these ones. The first one is what we call a relation. So, when I say a relation, is defined as a set of ordered pair. So when I say a relation, meaning that it's a set of what? Ordered pairs. Okay. What is a function? And according to my definition, I define it is a relation in which no two ordered pair have the same first elements. So the key here it is have the same what? First ordered have the first elements. That is the key of the function. How about a Cartesian product? You can say a Cartesian product is a set of ordered pairs where A and B are in this form, right? Where A is a member of set A and B is a member of set B. That's what it means. How about the ordered pairs? An element in the form of A, B, where A is in the member of what? Set A, and B it is in the member of set B. And where A is the first element and B is the second element. That's what it means. So this one here is the first element and this side is what? The second element. Okay. How about the domain? The domain is a set of all the first elements of the ordered pair. So if you have the elements of the ordered pair like that, right? So meaning that the one which is in the x-axis is the one which you call the domain, and this part here it is the one which is called a range. So if you look on the domain, you say a domain is a set of all the first element of the ordered pair. How about the range is a set of all second element of the ordered what? Pair. So meaning that this is the domain and this is the what? The range. So that's what it means there. Okay, now let's also look at what we call the inverse function. So if they ask you to define what an inverse function is, we say is a function that reverses the effect of another function. So, or in another way, the two can be the inverse of each other. If I've done f of inverse, then f of x, then the answer is supposed to be giving me what? X. That's what it means there. So that's what we call it's an what? Inverse function. Okay. Now, let's understand something about a function in fully. A function is called to be a function if, example, like that, right? So take this one to be your domain and take this one to be what? Your range. So here you have one is only has one range this side and two has only one range this side, and we call this to be what? A function. So this one it's a function. How about in another situation? In a situation whereby you have the domain this side and the range this side, right? So in a situation whereby, or a number where there is a domain here, it's having two domain like this, right? It's having what? Two domain. So for example, a domain is having two ranges, sorry, it's having two images this side, meaning that it is not a what? A function. Is it okay? So this one is not a function. How about a situation whereby you're having something like that? So two numbers only have one image. So this is a function because there is no repetition in the domain. So if there's a repetition in the domain, meaning that it's not a function. Or another example that I can give out. So if you look here, we are having something that is repeating, right? Since we're having something that is repeating, meaning that in the x-axis, we're having something that is repeating in the x-axis, meaning that this is not a what? A function. That's what it means, right? Unless it can be a function if there is no number that is repeating in the x-axis. If there is no number that is repeating in the x-axis. So for example here, in the x-axis, all of them are different, meaning that this is the function. So those are the main things that we need to take note of. Okay, now let's answer some question. Now let's look at this one. If you look at this one, they're saying which of the following relations are function from A to B? State the domain. If it's not a function, give a reason. So in this situation, what would be the domain? The x-axis, right? The x-axis, we have 1 there, then 3, then 4, then what? 8, like that, right? So we have 1, 3, 4, and what? 8. That's a domain. How about the range? The range, you have -2, then 7, -6, then what? -6. We are here -6, then 1, like that, right? Because we have -2, 7, -6, then 1, right? So those are what we call the what? The range. Now, if I may ask, do we have anything that is repeating in the x-axis here? In the x-axis. So in the x-axis, there is nothing that is repeating. So you say, therefore, the first one is a function because there is nothing that is repeating there. Okay, how about the second one? If you check out, you have 1 here, 1, okay, 2, then 4. So let's check out the domain. 1, 2, then 4. So only just 1, 2, and what? 4, right? How about the range? Is 0, -1, 3, and what? 10. That is the range, right? So what is your conclusion? We have checked out that we are finding the x-axis repeating. So you say is not a function. Why is not a function? Because 1 is repeating in the what? In the domain. That's the reason, right? How about the other one? Domain here, it's A, B, then C, then what? D. That's the domain. How about the range? The range it will be B, C, B, C, this is B again, then C. Here, we have just like that, right? That's a range. Now, do we have anything that is repeating in the x-axis? This is A, B, C, D. There's nothing. So, you can say is a function. That's what it means. Okay, how about the other one? this one, what would be the domain? The domain would be 2, 3, 4, 5, 6, right? How about the range? 4, 9, 16, 25, then 36. That's the range, right? So do we have anything that is repeating in the x-axis? No, because this is 2, 3, 4, 5, 6. So nothing that is repeating. So you say is a what? A function, right? So it's a function because there's nothing that's repeating in the what? In the x-axis. How about this part? You have the domain. Let's write the domain. That is A, B, do we have C? Yes, C, then D. How about the range? It's 1, 2, 4, then 5. Do we have 3 here? 1, 2, 4, 2, then 5. We don't have any 3. So here, what can be a conclusion in this situation? In this situation, a conclusion is that, let's check A. A here, in the x-axis, you have 2 A's here. So there's a repetition. So we say is not a function because A is repeating in the what? In the domain. That's what it means. That's all. Okay. Now, let's also look at the question based on the relation, right? So the question that are based on the relation are this one. That said, let A equal to 1, 2, 3, 4, 5, 6, 7, then 8, then up to 2/5, right? So in that situation, they are saying what is the relation exact? The relation is this one. They are saying is the cubic root of is a cubic, right? That's a cube root, right? Of in A. So what do you do in this situation? We'll be looking the cube root, right? The cube of A. So in this situation, you have 1. So you say you get 1. This 1. 1. What is its cubic? It is 1 times 1 times 1. It is still 1. Then you choose 2. 2 times 2 times 2. 3 times. So it is 2 times 2 times 2. What's the answer? 8. Is it among set A? Yes. It's correct. Then you also do 3. So if I say 3 times 3 times 3, what's the answer? It is 27. Is it in the in A? Yes. So you say 27. Then you go to 4. If I say 4 times 4 times 4, what is the answer? I shall get 64. Is it in A? Yes, still within. 5. 5 times 5 times 5. What's the answer? 125. Is it in A? Yes, so to be 5, 125. Then the other one, 6 times 6 times 6. So that is 216. Is it in A? So this is 216, right? Is it in A? Yes, it is in A, 216. Then how about 7? 7 times 7 times 7. So if you say 7 times 7 times 7, you shall find that 7 times 7 times 7, right? You shall find the answer is 7 times 7 times 7. The answer is 343. 343, is it in A? Is it a member of A? No. So meaning that we'll stop from there. That's what it means. Then, how about the inverse of the function? So the inverse of the function, what will be happening is that it will be changing. The x-axis or the domain becomes the range, and the range becomes the domain. So let's swap these ones, right? So this one will come this, and this one comes that. So it will be 1 still comma 1. Then this side it will be the domain, which is 2. It will become the range, which is there. Then 8, it will becomes the domain. So it will be 8 comma 2. Then what else? It will be 27 comma 3. Then there to be 64 comma 4. Then there to be what? 125 comma 5. Then 216 comma, oh yes, 216 comma 6. Just like that. Then what's the domain of the range? So this is the domain of range. That's the domain. The domain now, right, of the relation in short, which is of the first one. It will be what? 1, 2, 3, 4, 5, then 6. How about the range of the relation? The range now in this situation, it will be what? 1, 8, 27, 64, 125, then 2, 16, like that. So this is the for the relation in short. So we have the domain of the relation and the range of the relation. Okay, now let's look at of the inverse. Of the inverse, in this situation, you shall see the domain, right? So the domain, there it will be 1, 8, then 27, 64, then 125, then 216. How about the range? The range, it is 1, 2, 3, 4, 5, then 6. Just like that. Simple and straightforward. Okay, now let's also look at this one. If A equal to 4, 6, 8, 10, then B equal to 2, 3, 4, 5. Let R, that's a relation, right, be a relation from A to B, defined by X and Y are the members. X is a member of B. So they've said X is a member of B. Then Y is a member of A. Right? That's what they mean here. X is a member of what? B. Then Y is a member of A. So this means that since X is a member of B, what are B values? 2, 3, 4, then 5. Like that, right? And since Y is a member of A, what are the A values? 4, 6, then 8, then what? 10. Like that, right? So there I've said X, Y. So what is X? It's A. Then what's B? It's Y. What is X? Sorry, it is B, because X is a member of B. And what is Y? It is A. What is X is B. What is Y? It is A. So those are the differences that we need to face. And what are they trying to say there? They have said themselves that the relation is that X is a factor of Y. So meaning that X is a factor of what? Y. This means that B, it has some numbers that can enter into A. That don't leave a what? A remainder. So in this situation, you have the relation will be B, it is the X, right? B, it is the X. So we say 2. What numbers that it can enter into A without leaving a remainder? It is 2. 2 it can enter into 4 without a remainder. 2 it can enter into 6 without a remainder. 2 it can enter into 8 without a remainder. Then 2 it can enter into 10 without a remainder. Then 3 it can enter into 6 without a remainder. How about 4? 4 it can enter into 8. Or 4 it can enter into 4 without a remainder. Then 4 again it can enter into 8 without a remainder. Okay, how about 5? 5 it can enter into 10 without a remainder. Just like that. So what is the domain in this situation? So this is the first question. What is the domain? The domain in this situation will be 2, 3, 4, and what? 5. How about the range? How about the range? The range in this situation to be 4, 6, 8, 8, then what? 10. So this is the range. That's all. Simple and straightforward. Okay, now let's look at this one again. Let's say A equal to 1, 2, 3, 4, 5. Then B equal to 1, 3, 5. Be 2 sets. Right? Be 2 sets. Now, let R be a relation less than from A to B. They have said less than. From A to B, less than. So meaning that A is supposed to be less than what? B. So what would be the relation in this situation? The relation in this situation, it will be A is supposed to be less than B. So we have to say, if I get the 1 here to be 1, a number that is less than there, which is 3, so 1 is less than 3. Again, 1 is less than what? 5. Then if I get 2, 2 is less than 3. 2 again is less than 5. Then the other one, if I get 3, 3 is it less than 3? No, but it's less than 5. Just like that. Then I'll get 4. 4 is less than 3? No, but it's less than what? 5. That's all. Just like that. That's what it means there. Okay, now what is the relation inverse? We just swap now. So to be 3, 1, 5, 1, 3, 2, 5, 2, 5, 3, then 5, 4. That's what it means. Okay, now let's look at the domain for the relation. The domain of the relation is what? That is 1, 2, 3, then what? 4. How about the range? The range, it will be 3, 5. Yeah, 3 and 5. That's all. The domain of the relation inverse, the 3 and what? 5. Then the range, it's 1, 2, 3, then 4. Simple and straightforward, just like that. Okay, now let's also look at this question. Given that A equal to 2, 4, 5, 6, 7, then B equal to 2, 3. The relation is from A to B. Remember, from A to B. Then they say is by A, B, then A is a member of B, A is a member of A, then B is a member of B. A is divisible by B. So A is divisible. That's what they have said there. A is divisible by what? By B. That's what it means, right? So what would be the relation in this situation? Since A is divisible by B, this means that A is supposed to be divided by what? By B. A is divisible by B. So 2 can be divided by what number in B? Is 2 itself. Then 4, it can be divided by what number in 2? In B is 2. How about 5? No. How about 6? It can be divided by 2. 6 again, it can be divided by what? 3. Just like that, right? Do we have 7? No, it cannot be divided by anything. So you just end from there. So what is the domain in this situation? The domain is what? 2, 4, then 6. How about the range? The range is 2 and 3. That's all. Okay, now look at this one. If R is a relation is greater than from A to B, so is greater than from A to B. So I've said from what? A and what? To B. That's what it means, right? Is greater than. A is supposed to be greater than what? B. That's what it means, right? So there, what you do is the relation which will be, you start. 1 is greater than anything in B. No. How about 2? 2 is greater than 1. Correct, right? How about 3? 3 is greater than 1. Again, 3 is greater than 2 in B. Right? That's all. How about 4? 4 is greater than 1 in B, and 4 is greater than 2 in B, and 4 is not greater than 6. How about 5? 5 is greater than 1 in B, and 5 is also greater than 2, but 5 is not greater than 6. That's what it's there. So meaning that this is the relation which they are looking for. So that's the first question. How about the second question? The second question is finding the domain. So how do we find the domain in this situation? The domain, the x values. What are the x values? 2, 3, 4, then 5. How about the range in the y values? So the range in the y values, you have 1, 2, it's just 1 and 2. That's all. Okay, now let's go to the other one, which is say if A is equal to 4, 6, 8, 10, then B equal to 2, 3, 4, 5. R is the relation defined A to B. Then this is A, B. A is a member of A. B is a member of set B. And A, it is the multiple of what? B. So they've said that A is a multiple of what? B. That's what they've said. So if they've said something like that, that A is the multiple of B, so what do we do in this situation? Let's find now, right? Now A, it is the multiple of what? B. Okay, you go to B. What are the multiples of 2? This is 2, right? The multiples of 2 is 2 times 1 is 2. 2 times 2 it's 4. Then 2 times 3 it's what? 6. 2 times 4 8. 2 times 5 10. These are multiples of what? 2, which is 2, 4, 6, 8, 10. These are multiples of 2. Okay, now let's also look at the multiples of 3. So the multiples of 3 is 3 times 1 is 3. Then 3 times 2, it is what? 6. Then 3 times 3, it is what? 9. Okay, we can stop from there. So the multiples of 3, it is 3, 6, and 9. Also go to 4. So about 4 times 1, it's 1. Then 4 times 2. So 4 times 1, it's 4. 4 times 2, it's 8. Just leave it from there. Then go to the multiples of 5. 5 times 1, it is what? 5. Then 5 times 2, it is 10. Then 5 times 3, that's 15. But just leave it from there. Okay. Now they've said that A, it is a multiple of B. So since they've said that, what will be your relation? Your relation will be 4 is the multiple of what? It's a multiple of 2. Right? How about 6 is a multiple of what? It's also a multiple of 2. It's there. How about 8? 8 is also the multiple of 2. How about 10? 10 is also a multiple of 2. Right? Then 2, is it the multiple of 3? No. But 6 is the multiple of 3. So it will be, say, 6, 3, since that's the multiple. Then 8, it's a multiple of what? It's again the multiple of 4. 10, it's again the multiple of 5. Just like that. So meaning that the domain in this situation, what would be the domain? The domain in this situation, it will be 4, 6, then 8. What else? That is 4, 6, 8, and then what? 10. How about the range? The range is 2, 3, 4, and what? 5. That's all. Simple and straightforward. Okay, now let's look at this one. If R be a relation from natural numbers, this one's supposed to be natural numbers, defined by x, y, then the equation that you've been given is 4x plus y equal to 12, right? So remember, x and y are the members of natural numbers, right? Since all of them, these are the members of the natural numbers. So this means that we have x and y. So if I'll start getting the natural numbers, because everything is from the natural numbers. This is 4, this is 5, and this is 6. So I'll get everything of the natural numbers. So I'll put 1 there, plus y equal to 12. So this is 4. After putting 1, what number did I get after putting 1 in the equation? After putting 1 in this equation, what number should I put on the y? So our x is 1. What number should I put on y to have what? To have 12. So there it is what? 8. It is 8 because 4 plus 12. So what number should I put there where there's y to have 12? If I put 1 there, what number should I have? I put 12. So this means that this time that it is what? 4. Then plus that is 12. So meaning that if I put in 1, what is in the y? It is 8. Right? Okay. How about if I put 2 there? What number should I put for me to get 12? That is 8, right? Then 4. So meaning that the other one is, the x is what? 2, and the y is what? 4. Okay. And if I put 3, meaning that if I put 3 there, it will just go direct here to be 0, right? Now, is it 0 a member of the natural numbers? The answer is no. So the first element is 1, 8. The other one is what? 2 comma what? 4. So these are the odd one. What's the domain? The domain is 1 over and 2. The range is what? 8 and what? And 4. Just like that. And the other one, if R be a relation on the natural numbers defined by x comma x squared. X is a prime number less than 15. Okay, now let's write all the prime numbers that are less than 15 since that's x. Let's write all the numbers, prime numbers that are less than 15. So you have 2, 3, 7, what else? That is 9. That 9 is not a prime number. 11, then 13. So the other one is squared. So since the other one is squared, meaning that we'll be squaring x now. So it will be 4 here, right? Then after squaring that, that is 9. After squaring that, it is 49. After squaring that, it is 121. So after squaring 13, it will give me what? It will give me 169. So here our relation, it is 2 comma 5, 3 comma what? 9, 7 comma 49, and 11 comma 121, and 13 comma 169. That's what it means there. How about the domain? The domain would be 2, 3, 7, 11, 13. How about the range? The range will be 4, 9, 49, 121, and 169. That's all. Simple and straightforward. Okay, now let's look at this one. If R, the relation on a set of real numbers defined by x comma y, then x is squared plus y squared. What are the real numbers that I can put in the x and y to get me 0? So it is just a 0. So there it will be 0. Because 0 squared is 0, 0 squared is 0. So that's 0. So meaning that the relation there, it is 0 comma 0. What's the domain? The domain is 0. What is the range? The range again is what? 0. So simple and straightforward. Just like that. Okay, now let's look at this one. Let z, that is the positive integers, right, including 0. Then the statement is x is less than y. For all x and y are the members of positive integers. So what is the relation in this situation? The relation in this situation is that x is less than y. So meaning that again is they say including what? 0. So it will be the relation here to be 0 comma 1, then 1 comma 2, then 2 comma 3, then what? 3 comma 4. So it is just going just like that. That's all. Then this part, it says let a equal to 2 comma 3 comma 4 and b equal to 5 comma 6 comma 7 comma 8 comma 9 up to 12 in short. We define a relation R from A to what? To B. A divides B, meaning that A is the one supposed to divide B. So in this situation, our relation it will be 2. Which numbers that 2 can divide into B without a removing element? It's 6, 2 again 8, 2 again what? 10, 2 again 12. What else? 3, 6, then 3, 9, then 3, 12. Those are the numbers at which 3 can divide there without leaving a remainder. How about 4? 4 it can divide 8. 4 it can divide again what? 12 without a remainder. That's the thing that is they're looking for. Simple, straightforward. Okay, now let's look at this one again, which is the last one. They are saying that let A equal to 1, 1, 2, 3, 4, 5. Then 1, 4, 5 be sets, and let R be the relation less than from A to B. So here we're looking at less than from A to what? To B. So it's less than from A to B. So meaning that A is supposed to be less than there, right? Meaning that it will be 1 is less than what there? Less than 4. Again 1 is less than what? 5. How about 2 is less than 4? 2 again is less than what? 5 in B. Then 3 is less than 4. Again 3 is less than what? 5. Or 3 is less than 4. Again 3 is less than 5. Okay. How about is it 3? We are on 3. How about 4? 4 is only less than 5. That's all. What is the inverse? The inverse of that one, it will be 4 comma 1. The other one is 5 comma 1. The other one is what? 4 comma 2. The other one is what? 5 comma 2. The other one is what? 4 comma 3. The other one is what? 4 comma 3. 4 comma, that is 5, sorry, so this is a mistake. 5 comma 3. Then 5 comma 4. On the relation, what is the domain? It is 1, 2, 3, 4. How about the range? It is what? 4, 5. It's just 4 and 5, yeah. How about the inverse? So the domain there, it is 4 and 5 on the inverse. And on the range, it is 1, 2, 3, 4. Just like that. So that is how we answer the questions based on relation and what? Functions. That's all, just like that.